Thank you. Thank you. Thank you. Thank you. All right. So let's talk about B. It seems we're pretty okay with the multiplying part. Is that fair to say?
No.
Yeah? Okay. So once you multiplied it out, I think we got 5x. Oh, we already did this. I'm not multiplying it out. I've got a lot of people who are looking at me like, Mr. Kinney, I have no clue how to graph this. Okay? I've already talked with those a little bit, but here's something else I want to point out. When we multiplied it, with what form did we get? 5x squared plus 11x plus 2? That's standard form. Hey, when I look at standard form, is there any point that I should know right away?
0.
The y-intercept. Remember, the zeros, the roots come from factored form. When I see standard form, I should find the y-intercept. Because what do we automatically know about x when we're looking at a y-intercept? X is equal to 0. So 5 times 0 squared, that's going to be a 0. What's 11 times 0? A 0. And so I'm just left with 2. So I know that I have a y-intercept of 0, 2. That's something we should notice right away. If I have standard form, I have my y-intercept. Okay? From there, what were the other 2 points that we should notice from factored form that are really important every single time? Zeros. Remember, the idea of a 0 comes from x plus 2 times 5x plus 1 equaling what? 0. Those are critical things to recognize. I got a y-intercept from standard form. I've got my zeros from factored form. Now, don't forget, from here, we set each factor equal to what? 0. What allows me to go from this factored form to each factor equaling 0?
Zero product property.
The zero product property. Remember, that's something we've talked about recently, where if I have A times B equal to 0, what do I know has to be true? Either A is equal to 0 or B is equal to 0. That's all we're doing here. One of those factors has to equal 0. And then we solve that equation, x equals -2, and x equals -1/5, or -0.2. You need to show me algebraic work for these points. And that's a good start. Now, what's the other point that we do still want? The vertex, right? Use your technology to help you find that. If you look for a relative minimum, I think it was -1.1 comma -4.05. Sound right? So there's -1, -1.1, 1, 2, 3, 4, just a little bit past that. So this may not be perfect, but I got some good points there to kind of sketch this out. Boom. Done. I got to keep making sure it's going up and out, and don't make it too steep, but that's a pretty accurate graph. Use your knowledge of the different quadratic forms to help you graph that function. Questions, comments, concerns?
No, sir.
Okay? Now, we didn't quite get a chance to look at D as heavily as I wanted to, but let's go through D pretty quickly. Actually, I do want to point this out even before we look at D.
No, go ahead.
Look at number 3. Max determined the product of 3 linear factors. He said the function f of x equals x plus 2 cubed is equivalent to x cubed plus 8. Notice it's the same mistake Chloe made. And I know she's going to be upset that I said her name. It's okay, right? Mistakes are common. Do you know why this is what they wrote here? Because every math teacher sees students do this time and time and time again. Learn from that mistake, okay? Notice we can check it graphically. But let's go back. Right? So x plus 2 times x plus 2 times x plus 2. How many factors can I multiply at a time?
2.
Just 2. So only x plus 2 times x plus 2 is where I'm going to start. I'm going to use that area model. Multiplying x plus 2 and x plus 2. I would at least copy this down as we're going through it. X times x. 2 times x. X times 2. And 2 times 2. 4, right? Notice I've got like terms right here. And so remember, I am getting an equivalent form of this x plus 2 times this x plus 2. So I have x squared plus 4x plus 4. But I am not done. that still needs to be multiplied by what? X plus 2. So I have to use either distribution or area model again. So I'm going to make that column and that row for my first, or for one of my factors, and then x squared, 4x, and 4. And I need to make sure I'm multiplying, right? So x cubed, 2x squared, 4x squared, 8x, 4x, and 8. So I'm going to combine those like terms. Just remember we're adding. So the final product should have been x cubed plus 6x squared plus 12x plus 8. Notice we would have been missing all of that middle stuff. Is there an x cubed?
Yes.
Yep. Is there an 8? Yep. But you're missing all that middle stuff if you just distribute that cube. So pay attention and let's check. So write that down. I'm going to type in the equation to see if that is correct. X cubed plus. Ah. So is this correct? Yeah, notice we can map it to the other function over there. So pay attention to your y-intercept, pay attention to your x-intercepts, and that should be enough. Alright. So that is overall the end of lesson 4. We'll do a little bit more practice with things tomorrow. But remember, we got an understanding check right now.
No.
Yes.
Yes.
Remember, show me what you know. So clear off your desk. You can start on it, but I will pause you in just a second to point out a couple of details that turn
Get
out.
ready to work.
Sir? Kadeja, we've been turning it in for the last 2